Let's dive right into this explainer. Today, we're urgently breaking down the paradigm shift required to secure AI agents. As we enter this era of autonomous systems, relying on traditional security is honestly a recipe for disaster. We need to completely rethink our approach by using automated policy as code to secure agentic AI identity. Let's start with the very real, severe threat introduced by agentic autonomy. When a human account gets compromised, that adversary still has to manually navigate the system, figure things out, and execute their attack. But when an AI identity is compromised, the blast radius expands way faster than any human security team could ever react. Rogue AI agents operate at machine speed. They can exploit dynamic access and chain tools together in literally milliseconds. And that brings us to a core problem identified by the OWASP Agentic Security Initiative, the confused deputy vulnerability. It helps to think of the AI as a highly capable but overly trusting deputy. It holds high privileges, sure, but it lacks proper isolation. So when it interfaces with an attacker, say through a cleverly crafted malicious prompt, it actually can't distinguish between a legitimate user request and an adversarial instruction. As a result, it executes unauthorized actions right on behalf of the attacker. Now, looking at this architecture, you can see exactly where these vulnerabilities strike. If you trace the flow between the agent, planning, action, and tools, it becomes clear how attackers exploit those tools and action pathways to completely bypass intended security controls. Even if an individual tool API is perfectly secure, an agent with too much operational freedom can chain multiple tools together in totally unexpected ways to, say, exfiltrate data. To fix this, we're going to architect a definitive blueprint for senior design authorities. We'll cover Enter Policy as Code, Framework 1, Least Privilege, Framework 2, Ephemeral Credentials, Framework 3, Adaptive Authorization, and finally, Securing the Lifecycle. All right, Section 1, Enter Policy as Code. The contrast here is absolutely everything. Manual rules were built for humans logging in and out. But AI agents, they are non-human identities. Legacy identity and access management systems just fail here because agents do not work like humans. They dynamically chain tools, they access long-term memory, and they inherit excessive permissions without any standard session-based oversight. Policy as Code replaces those static rules with automated programmable policies that can actually govern autonomous agents at scale. Moving on to Framework 1, Least Privilege Access. This framework is our frontline defense against that confused deputy vulnerability we just talked about. By using code to enforce strict boundaries, we guarantee agents operate with the absolute minimum permissions necessary to complete a specific task. We implement granular scoping, using role-based and attribute-based access control to lock down specific APIs. But we also do prompt validation, verifying that the human user triggering the agent actually has the authority to request that action. We also set strict tool restrictions. For example, your policy should actively prevent an agent from using a search tool and an email tool in a single, unvalidated sequence. And in multi-agent systems, we enforce task segmentation to stop an attacker from escalating privileges across a whole network of interconnected agents. Next up, Framework 2, Just-in-Time and Ephemeral Credentials. To really shrink that blast radius, we have to eliminate standing privileges entirely. If an agent doesn't need access right this very second, it shouldn't have it. We achieve this through a just-in-time, or JIT, lifecycle. The policy dictates that access is granted only at the explicit moment it's required. The agent requests tool access, a temporary token is dynamically provisioned, the task executes in a sandboxed environment, and then, this is key, the access is automatically revoked immediately after the task is finished. And before any of those temporary tokens are even considered, the framework demands cryptographic identity attestation during the agent's actual birth or registration process. From there, credential lifecycle management is handled using highly restrictive, short-lived API keys. By coupling this JIT access with execution sandboxing, we ensure that AI-invoked tools run in isolated containers that are completely destroyed after every single execution. This absolutely blocks lateral movement if an agent happens to be hijacked. Framework 3, Risk Adaptive Authorization. This framework shifts us away from simple, binary, allow or deny logic into dynamic, context-aware security. This table maps out how our dynamic governance models adjust on the fly using intervention thresholds. In a low-risk context, automated execution is fine. But as risk scales, the policy demands more. For medium risk, we enforce contextual memory access, meaning the agent can only pull long-term memory that is absolutely relevant to its current operational task, preventing unauthorized knowledge extraction. And for high-risk, mission-critical actions, the policy as code actively enforces multi-agent consensus, dual-agent verification, or it just kicks the decision up to human oversight. To make this work, we implement real-time risk scoring. We literally use AI to police AI. We run a secondary AI model dedicated solely to behavioral profiling. It continuously monitors the primary agent's activity against historical profiles, instantly flagging deviations that might indicate identity spoofing, rogue agent behavior, or unusual data access. If risk thresholds are exceeded, tool execution permissions are automatically adjusted. Finally, securing the agent lifecycle. Bringing it all together, these three policy as code frameworks, least privilege, ephemeral credentials, and adaptive authorization, cannot just be applied as an afterthought. As a senior design authority, you have to embed them deeply into the agentic lifecycle, from birth right through to decommissioning. Because implementing full traceability across agent actions and privilege usage isn't just a cool technical best practice to stop threats, it's a strict regulatory and compliance mandate. Whether you're partnering with cyber, risk, or compliance teams, your AI identity architecture has to stand up to PCI DSS, SOC 2, ISO standards, and all the emerging AI governance laws. So I want to leave you with this critical question to evaluate your own systems today. Look closely at your identity infrastructure. Autonomous agents are already here. They are pulling data, chaining tools, and acting on behalf of users right now. And because of that, they require autonomous security. Is your AI identity architecture operating at machine speed, or are you still relying on human speed security rules?